When we imagine the Mesozoic era, our minds often conjure images of colossal dinosaurs thundering across ancient landscapes. We picture the long-necked sauropods and the fearsome Tyrannosaurus rex. Yet, ruling the skies above them was another group of extraordinary reptiles. These were the pterosaurs, often mistakenly called flying dinosaurs. They were, in fact, the first vertebrates to achieve true powered flight. For over 150 million years, these magnificent creatures soared, flapped, and glided through prehistoric air, long before the first birds took to the wing. Their dominance of the aerial realm was absolute, a testament to their remarkable evolutionary journey. The term pterodactyl is a common, almost household name, but it technically refers to a specific genus, Pterodactylus. This small pterosaur was one of the first to be discovered in the late 18th century in Germany. Its discovery was revolutionary, challenging the scientific understanding of prehistoric life. The name itself, meaning wing finger, perfectly captures their most defining feature. However, the broader group, Pterosauria, encompasses a breathtaking diversity of species. From creatures no bigger than a sparrow to giants with the wingspan of a small airplane, they were a varied and successful group that adapted to fill numerous ecological niches across the globe. Their evolutionary story begins in the late Triassic period, around 228 million years ago. Early pterosaurs were relatively small, with long tails and teeth suited for catching insects. As they evolved through the Jurassic and into the Cretaceous periods, they diversified spectacularly. Some developed enormous sizes, others lost their teeth, and many grew elaborate, bony crests on their heads. This incredible radiation shows just how successful their blueprint for flight was. They were not clumsy gliders, but sophisticated flyers, masters of the Mesozoic skies who witnessed the rise and fall of countless dinosaur species from their unique vantage point high above. Understanding pterosaurs means appreciating them as a distinct and highly successful lineage of archosaurs, the same group that includes dinosaurs and crocodilians. They were not an evolutionary side note, but a major component of Mesozoic ecosystems. They weren't just passively drifting on the wind, they were active, dynamic animals. Their story is one of innovation, adaptation, and ultimate mastery over an environment that no vertebrate had conquered before. They truly were the original lords of the sky, setting the stage for all flying vertebrates that would follow them millions of years later into the future. The key to the pterosaur's success was its radically adapted anatomy, engineered for life in the air. Their most striking feature was, without question, their enormous wings. Unlike the feathered wings of birds, a pterosaur's wing was a membrane of skin and muscle known as a patagium. This membrane stretched from the side of the body to the tip of an incredibly elongated fourth finger. This wing finger was a marvel of evolution, providing the primary support for the wing's surface. The other three fingers on their hands remained small and clawed, likely used for climbing or grasping onto surfaces when they were on the ground. To make flight possible, pterosaurs needed to be incredibly lightweight. Their bones were hollow, much like those of modern birds, but with even thinner walls. These pneumatic bones were filled with air sacs connected to their respiratory system, reducing their overall body weight without sacrificing structural strength. This adaptation was crucial, especially for the larger species. A giant like Quetzalcoatlus, with a wingspan of over 10 meters, would have been far too heavy to take off if it had solid bones. This skeletal lightness was a fundamental part of their design, allowing them to become airborne with surprising ease. Many pterosaurs are also famous for their spectacular head crests. These structures came in an amazing variety of shapes and sizes. Some, like those on Pteranodon, were long, bony projections extending from the back of the skull. Others, such as the crest of Tapejara, were made of both bone and soft tissue, forming a large, sail-like structure. For a long time, paleontologists debated the purpose of these crests. Today, it is widely believed they were used for display, helping individuals recognize members of their own species, attract mates, or intimidate rivals, much like the elaborate plumage of modern birds. Beyond the wings and crests, their bodies were covered not in scales, but in a unique hair-like filament covering called pycnofibers. This discovery was significant because it suggested that pterosaurs were warm-blooded. A furry covering would have provided insulation, helping them maintain a constant body temperature needed for the high-energy demands of powered flight. This detail transforms our image of them from cold, scaly reptiles into active, fuzzy, and dynamic creatures that were far more complex than early discoveries ever suggested. They were truly unique animals, unlike anything alive today. The behavior of pterosaurs was as diverse as their physical forms, shaped by the demands of flight and their specific environments. Soaring was likely a common strategy, especially for the larger species with long, narrow wings such as Pteranodon. These giants of the sky could use thermal updrafts and ocean winds to glide effortlessly for vast distances, much like a modern albatross. This energy-efficient mode of travel would have been perfect for scanning the open ocean for food. They would circle high above the waves, their keen eyesight searching for the telltale shimmer of fish near the surface, waiting for the perfect moment to descend. When it came time to hunt, different pterosaurs employed different tactics. Many coastal and marine species were expert fishers. Some may have skimmed the water's surface, dipping their beaks to snatch fish, a behavior once proposed for Rhamphorhynchus. Others, like Pteranodon, probably behaved more like modern gannets, plunging into the water from a height to catch their prey. Evidence from fossilized stomach contents confirms that fish formed a major part of their diet. The shape of their beaks, whether long and needle-like or broad and pelican-like, gives us clues about the specific type of prey they targeted and their preferred hunting style. Life wasn't always spent in the air. When pterosaurs landed, they had to move around on the ground. For a long time, scientists thought they were clumsy and awkward on land, perhaps crawling on their bellies. However, fossil trackways have revealed a different story. These tracks show that pterosaurs were surprisingly capable quadrupeds, walking on all four limbs. They would fold their long wings neatly at their sides and walk with their feet and wing hands, a posture that would have been stable and surprisingly efficient. They likely rested on cliffsides or in trees, using their small, clawed fingers to get a secure grip. These nesting and resting sites would have been bustling colonies, especially along coastal cliffs and inland rock formations. Imagine a sheer cliff face dotted with hundreds of pterosaurs, preening their pycnofibers, tending to their eggs, and launching themselves into the air. This colonial behavior is suggested by fossil finds where numerous individuals of different ages are found together. Such colonies would have offered protection from predators and provided a social hub for mating and raising young. Life for a pterosaur was a dynamic cycle of soaring, hunting, resting, and socializing, all playing out in the skies of a lost world. The habitats of pterosaurs were as varied as the creatures themselves, spanning across the globe and persisting through millions of years of environmental change. During the Jurassic period, many pterosaurs, like the long-tailed Rhamphorhynchus, thrived in coastal environments. The Solnhofen limestone in Germany, where many of these fossils are found, was once a series of subtropical lagoons. Here, they would have hunted fish in the shallow waters and insects in the air, sharing their world with early feathered dinosaurs like Archaeopteryx. These coastal settings provided ample food and safe nesting sites on nearby islands and cliffs. Moving into the Cretaceous period, pterosaur diversity exploded and they colonized a wider range of habitats. The famous Pteranodon is strongly associated with the western interior seaway, a vast inland sea that split North America in two. Fossils of this toothless giant are found hundreds of kilometers from any ancient shoreline, suggesting it was a pelagic soarer, spending most of its life over the open ocean. In contrast, the colossal Ajdarchids, a group that includes Quetzalcoatlus, are often found in inland terrestrial deposits. This suggests they were not sea flyers, but stalkers of the prehistoric plains. These terrestrial giants, the Ajdarchids, represent a fascinating shift in pterosaur lifestyles. With their incredibly long necks and legs, they likely behaved like giant storks or ground hornbills. Instead of soaring over oceans, they would have stalked through fern prairies and floodplains, using their long, sharp beaks to snatch up any small animals they could find. Their prey would have included small dinosaurs, lizards, and other vertebrates. This image of a pterosaur walking confidently on the ground, hunting like a terrestrial predator, shatters the old stereotype of them being exclusively seafaring fish-eaters. From the coastlines of Jurassic Europe to the plains of Cretaceous North America and the forests of Asia, pterosaurs were a global success story. Their fossils have been discovered on every continent, including Antarctica, proving their incredible adaptability. They were not a monolithic group but a rich and varied dynasty of flying reptiles. Some ate fish, others insects, some were filter feeders, and some were formidable terrestrial predators. Their reign finally came to an end 66 million years ago, alongside their non-avian dinosaur cousins, but their legacy as the first masters of vertebrate flight remains etched in the fossil record.